We can also draw the Lewis structure of a polyatomic ion. And a polyatomic ion, polyatomic means many atom, so it's a many atom ion. So an example is the nitrate ion. Now we'll follow the same ideas that we would follow for a regular Lewis structure. So if we recall, you set up the skeletal arrangement. Nitrogen would go in the middle with the oxygens around it. And then we add up the valence electrons. Nitrogen is in group 5A, so it has 5 electrons. Oxygen, we have 3 of them in the formula. They're in the group 6A, so there's 6 of them times 3, because there's 3 oxygens, and that gives me 18 electrons. And so 18 plus 5 is 23 electrons. Now here's where the difference comes in. A polyatomic ion is going to have a charge, and nitrate has a -1 charge. They could have -2, -3, or even a +1. A negative, when we have a negative charge, remember that means we have added an electron. So what we have to do to our total of valence electrons is just because of the charge, we add an electron. So down here, I'm adding an electron because of the charge. So instead of using 23 electrons, my structure is going to need to use 24 electrons. So remember, you draw single bonds between all of the atoms. Then you take the remaining electrons and complete the octet of the outer atoms. The reason we complete the octet of the outer atoms first is because if there is going to be any exception in later courses, it's always on the inner atom. So make sure the outer atoms are happy with their 8. Remember, the only one that won't have 8 is in the hydrogen. Hydrogen can only have a single bond. So now let's count up how many we used, and I'm going to use the highlighter for this. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so I've used 24 electrons, which means I am at my limit of 24. So I can't add any more electrons to this structure. And when I look at nitrogen, it only has 2, 4, 6 electrons. So nitrogen's not happy, it needs 8. Remember, what that tells me is if I've used all my electrons and my central atom's not happy, is that there must be a multiple bond, a double or a triple bond. So how we figure that out is we take one of the lone pairs, and it wouldn't matter which one I used. In this case, I could put a double bond between any 3 of the oxygens. Remember, that is called a resonance. There would be 3 equal resonance structures here because I could put the double bond between any one of the oxygens. So I went ahead and took the lone pair off this left oxygen and made it into a double bond. Looking at it, each atom is still happy. They have 8 electrons around them. And now, so I have completed it. Now, in ions, when it's a polyatomic ion, a lot of times to complete the structure, they'll write a bracket and then on the outside put a charge. In chemistry, a lot of it is about communicating through our pictures and the formulas, what's going on. And so by drawing the bracket with the charge, it shows that this is an ion and that we added that extra electron to the valence electrons.